Here, russet mounds of a pregnant ore tower, thrusting up their bulk, with pride they bear beneath their slopes the substance of the power to be released through man's all-knowing care. In awesome mass, sharp-etched gainst fiery cloud, the cauldrons of terrible heat and searing blast summon a titan who sleeps within a shroud of impure earth, of dross until it's cast. He will not serve unless he be given form. But grant to him the endless aching toil of eager, questing, strong and visioned men. Give him their ardent hopes, their courage bold, their brains, their sweat, their strength. Now let the potion boil 'neath bright and purifying flame. Then, with a power awful to behold, let him be formed, and steel shall be his name. Today's steel mill is the mightiest and most important machine ever to be turned by human hands. And the story of the Iron Masters is more fabulous than any legend, more epic than any story out of Homer. This is the Vulcan Forge, the Promethean furnace, visioned in man-made myth, made real by myth-dwarfing vision. Here are the deep, long, endless flame-drenched caverns where metal boils and rumbles. Here is the fiery pit. Here is the inferno. This is the masterwork. This is the immense, the overpowering spectacle of a steel mill. And the plot of its story is how man became a giant. For the genius of a steel mill is the genius of the people. Each man is the custodian of the heritage of the steelmaker. From the earliest days of the industry, the mills and the furnaces have been built by the rivers and watercourses. But the greatest of all industrial waterways, carrying more commerce than the Suez and the Panama together, is the curving ribbon which flows past the city of Detroit. Now the like of this city is known nowhere in the world. Birthplace of the motor car and home of the automotive industry, this vast industrial complex is the largest consumer of finished steel on the whole map of our world. Of the huge commerce which, reaching down the Great Lakes, passes through the Detroit River, the greatest tonnage by far is in the rich cargo of the long ore boats. Near the upper reaches of the Great Lakes, south and west of the Superior, were discovered one of the world's greatest iron deposits. In almost inexhaustible supply, the ranges have yielded thousands of millions of tons of rich iron ore to the great shovels which cut grand canyons into the woodlands. From the deep open pit mines by rail car along the trestles to the docks of Duluth and Superior, where the great ore boats are ready. Down come the chutes and iron ore rushes into the boat holds. From the Northland, down the Great Lakes, the ore boats steam toward the steel plants. For many years, they were a familiar sight as they moved past the automotive city. but they were only of passing interest. The river was merely a stage in the journey. But to some it seemed illogical that all the ore boats should sail right on past the city. Why shouldn't steel be made and processed right in the area where such a vast amount of steel is consumed? It was for a steel man to sense the contradiction, to see the obvious solution, to make a dream a reality. The only suitable location had every advantage, except solid ground. The site selected was a swampland, a bog on the banks of the river. To work went the fillers and haulers. 4 million cubic yards of earth were needed to fill in the area. To work went the pile drivers. $100,000 piles were driven to bedrock. And so the miracle was made. 275 acres of waste marsh were converted into a usable industrial plant site with firm foundations for the mighty mill machinery. And in due time, through single-minded purpose and force of will, one of the largest and most modern of integrated steel plants was erected on the banks of the Detroit River. All was ready. Then, on a memorable day, in a glaring light, hot metal was poured, and the strength of an ideal had held secure. 15 months after the starting of construction, the first heat of steel was tapped from an open-hearth furnace. The great steel mill stands today, giving employment to many thousands, giving a vast industry the advantage of nearby supply, providing the area with a rich new enterprise. The furnaces blaze without interruption. The hot steel rolls on and on. The men and mills stand solidly together. In coils and sheets, in numerous useful forms, like an endless avalanche, finished steel pours out of the shipping gates on huge trucks and trailers in countless rail cars. The mill delivers the goods to a huge steel-hungry industry. Another dawn breaks over the river upon a scene of dramatic significance. Now the Great Lakes Steel Plant on the Detroit River is the home port for the ore boat. Secure the hawsers quickly. Down comes the clamshell bucket into the laden hole, biting up many tons to the mouthful. The buckets and cranes eat into the cargo. This is the destination of 12,000 tons of rust-red earth whose destiny is steel. No rest for the ore bridges, the cranes, and the big shovels, for they serve the hungry furnaces who day in and day out, for years and years, never cease to devour iron ore. From boat hole to ore pile, from ore pile to transfer car, and thence off to the stockhouse, where it meets the limestone from the quarries of Ohio and coke from the nearby ovens. The push is on. Out comes a rail car full of golden, blazing, hard, porous coke lumps. The glowing carload moves into the quenching house. The fires are drowned in 6,000 gallons of water, and a thunderhead of steam balloons skyward. Now journey's end, as the skip hoist dumps successive layers of coke limestone and ore into the top of the blast furnace. As the mixed burden makes its way down through the blazing interior of the furnace, the blast of superheated air is injected through the tweers below the waist of the giant and the iron ore is reduced to molten iron, which collects in the hearth at the bottom of the furnace. Now it's time to make the cast. The tap hole is opened by burning with a long oxygen lance. The white-hot iron comes rushing, a river of molten iron, basic iron, from which steel is made. These are the iron men who work the furnace, who follow a strange and fascinating calling. The blower watches with understanding eye the golden stream of metal. Over 100 tons of iron are poured into each of the fire brick-lined thermos cars. Now they're on their way, a 2.5-mile journey from the blast furnace division to the main plant down the river. At the end of the line, they enter the plant, bringing a white-hot burden of molten pig iron to be stored in an enormous vessel called the hot metal mixer. The thermos cars spill their fiery contents into an 80-ton ladle. The hooks of an enormous crane engage the ladle and begin to lift it. Now it's up to the crane operator, who must lift this burden slowly, smoothly, to the mixer 60 feet above the floor. The lid is lifted from the tiny mouth of the giant vessel. As through a needle's eye, he aims the flowing metal straight and sure into the awesome kettle. With deft fingers on the controls, the operator slowly tilts the cauldron into the devil's own reservoir, where 1,500 tons of liquid iron are kept at uniform temperature and composition. This is the abiding place of flame and inferno. The hot mouth of the converter is ready for the waiting Bessemer. Molten pig iron from the nearby mixer moves up on a rail car. Tilt the ladle and let the metal flow. The Bessemers are never for a moment idle. As the big converter is tilted up again, a mighty blast of air is forced through the metal from below. Far above and safe behind the heavy glass and steel, two operators control the Bessemer with a selection of levers. The regulator has handled the tilting of the vessel. The blower takes over when the conversion process is started. In a matter of minutes, the air forced up through the metal oxidizes a large portion of the undesirable elements and literally blows them skyward. By the color of the flame, the blower knows when the brew is finished. These are the torchlights of steel land, throwing their golden roaring beacons through the roofless rafters. Down again comes the Bessemer, spilling its contents into another enormous ladle. The blown metal is ready to move on to the steel-making open-hearth furnaces. But other ingredients are required in the making of steel. In the scrap stockyard adjacent to the open-hearth building, cranes and magnets are busy loading the charging buggy trains. Scrap is precious, since it is mostly steel ready for remelting. and a charging buggy train loaded with scrap, limestone, and other materials rolls into the Open-hearth building. Each of the great furnaces is operated from the far side of the charging floor. A push of the controls and the massive doors of the furnace are open. The charging peel pushes and dumps the scrap and limestone into the hot belly of an empty furnace. Materials such as silica manganese, ferromanganese, and spiegeleisen are added in the same manner. The proportion of materials charged into the furnace must be far more exact than the most delicate recipe followed in the kitchen. The operator adjusts the fuel valves. The heat is on. And the flames from one of the great nozzles at either end turns the interior of the furnace into an inferno. First, the massive load of scrap and limestone is melted. Then, ladles of blown metals from the Bessemer converters enter the Open-hearth building on rail cars. Picked up by the mammoth overhead crane, the enormous vessel is carried down the long charging floor of the Open-hearth building. And never a drop is spilled, for the operator above and the men giving instructions from the floor level work as smoothly together as a conductor and a symphony orchestra. Here again, it's precision and skill, the cool, clear-headedness which guarantee the safe handling of 75 tons of liquid metal at over 2,500 degrees Fahrenheit. The men with the shovels go to work immediately, for the dikes of cinderlag must be built up around the doors to prevent the seething bath from splashing over. Each man in his turn faces the inferno. Like the basting of a roast, it's warm work for the chefs who preside over the cooking of iron into steel. And now the long vigil. Now comes the sensitive art of steel making. The flames play on the bath of metal for hours as the material is cooked in the great reverberating oven. Delicate instruments register degree of heat, airflow, gas flow, pressure, and other vital information. With eyes protected from the dazzling glare by cobalt blue glasses, the melter watches the heat as a housewife would a Thanksgiving turkey. Steel is a relatively pure form of iron, containing exact and limited amounts of carbon and other elements. In the ordeal by fire, most of the impurities react chemically, becoming stable compounds, and are made captive by the slag. Now it's time to reverse the air blast. Alternate the checker valves. Now adjust the fuel flow. All is well, and the running data are recorded on the heat log. Time to take a sample. The exacting specifications of quality steel demand that the chemical composition of the white-hot mixture be repeatedly checked by the laboratory. Better drop your glasses. The glare is awesome as the small levers open the doors of the furnace. Take another look. Let's see how she's cooking. Let us look straight into the mouth of this oven. That's steel in a rolling boil, spouting and splashing with fury. The hours go by, and the flame roars on. Then the moment comes. Stand by for the ramp. They're cutting in with oxygen at the far side of the furnace. Ram it, ram it. Cut it deeper. Finally, it breaks through. The hearth has been tapped. and steel at nearly 3,000 degrees floods out into another great ladle on the pouring aisle. Over 200 tons gush out into this massive vessel. The lighter slag rises to the top and runs off into the slag pot. Now work for another of the steel plant's giants, the crane, which smoothly carries the pride of the open hearth to the ingot mold line without swaying or tilting. As the stopper rods are lifted, the molds are filled in pairs. Samples are caught and sent to the laboratory. Here in the Teeming pit, the ladle of steel will be poured into huge cast iron molds. These men are like salamanders. They can really take the heat. The ladle empties its contents. Then the ingots move along the rails to the stripper building. The great claws and steel finger of the stripper crane separate the molds from the ingot, solidified on the outside but still molten within. Since the ingots do not cool uniformly, they must be heated to bring them to an even temperature for rolling. From the cooling yard, the ingots are transferred to the soaking pits. Soaked in an atmosphere of 2,400 degrees, soaked for several hours to equalize their temperature. Each pit has its individual fuel and air supply. The wheel adjusts the airflow. And the lever on the fuel pipes controls the fires in the pits. Heat number and classifications are recorded by the tallyman in a continuous running operation. And there's the signal for another ingot. The operators on the control balconies slowly draw back the cover of the pit. It is opened and closed electrically by remote control. One of the powerful cranes which serve the great bank of 60 soaking pits is ready to remove the ingot. The tongues grasp the ingot firmly and lift it from the pit. And away it goes to be rolled in the mills into sizes and shapes of useful steel. The 12-ton glowing mass rolls down the conveyor to the blooming mill. And the men in the control pulpit, safe behind shatterproof glass, are waiting and ready for its coming. Watch how the great yellow-white ingot is pushed about and slapped around by the jaws and rollers of the bloomer. The purpose of this massive machine is to roughly reduce the big heat-softened ingot to a size and thickness suitable for milling. Watch the nimble hands of the operator. In about 3 minutes, with approximately 20 passes between the driven rolls, the ingot is reduced to a slab less than 5 inches thick and 45 feet long. Now the enormously powerful shear crops off the ends. The heavy slab is cut into lengths of from 5 to 16 feet. The steel mill represents the ultimate in the brilliant engineering of heavy handling systems. The big hot slabs are conveyed to the slab cooling yard by a process which is completely mechanized and almost entirely automatic. The slabs are carefully labeled, waiting for repair. Like a 4th of July celebration, the brilliant cascades of showering sparks characterize the scarfing process. Every surface defect is burned off the big steel slabs with an oxygen torch. This ensures that that the finished rolled steel strip will be free from imperfections. After the fiery scrubbing, the great steel slabs must be heated again to the rolling temperature. Then out of the slab heating furnace and down the skids, the red-hot steel starts its jolting, crashing journey along the 2,000-foot steel mill. The first savage shock is at the scale breaker, where the water, under 1,000 pounds of pressure, washes the glowing steel clean. Then on through the spreading mill. The big squeeze is on. Now it's headed for the 3 mammoth universal roughing mills. A mill of this capacity is a thing of tremendous size. Consider the massiveness of these mill stands. The 2 smaller working mills are backed up by 2 65-ton friction-driven rolls which really apply the pressure. By this time, the steel slab has been rolled out thin, and it slides along the roller table towards the first of 6 finishing mills. Let's follow the hot steel through one of the world's largest and fastest continuous strip mills. The stands are so close that the strip is passing through all 6 at one time. The hot steel runs the gauntlet under the personal attention of the men in the balcony who pushed the buttons and pressed the levers, keeping the situation strictly under control. The speed at which the rolls turn must be synchronized to split-hair accuracy with the increasing speed of the moving sheet as it becomes thinner and longer. Watch the temperature of that moving metal. It must stay hot enough to roll. That's an optical pyrometer in the observer's hand. In the motor room is the power that runs the machines. Enough power to light the homes of a city of 1 million people. 6,500 motors, ranging in size from 1/4 to 8,700 horsepower, are used to drive the various mills in this plant. At the far end, the finished strip races through the rotary flying shear. Near the end of the hot rolling process, the strip of steel, over 90 inches wide and hundreds of feet long, has reached a speed of almost 25 miles an hour. And the rippling sheets race along the rollers of the delivery table. Steel that is not to be cut into sheets moves from the final finishing stand in a long, continuous ribbon to the hot strip coilers. Compactly coiled, it may become sleek automobile bodies or go into stoves or refrigerators. Upended onto the loading conveyor and marked for identification, the tremendously heavy coil of steel is ready for the pickling department. Stitched together, the strips of steel move in an unending band through the long pickling vats. Then, emerging from the picklers, the strips are cut, recoiled, and conveyed for further processing. Here again, we are impressed by the effortless power of the amazing handling machinery which does the work of lifting and toting in a modern steel mill. The big coils are being moved to another set of mills for cold reduction. Like a huge roll of newsprint, the steel is inserted between the rolls of the first of 3 big cold reduction mills. So much heat is generated in the rolling process that the cooling spray of water is instantly turned to steam. With small levers, the expert operators compel these massive machines to do their bidding. Despite the enormous size of the machines used, cold steel rolling is a precision process. fingertip controls adjust the massive mills which are capable of reducing cold steel to less than half of its original thickness. The gauge of the metal is measured with an electric micrometer, continuously and accurately checking the thickness of the cold reduced steel. The steel emerges from the cold reducing mill to be wound evenly in shining coils. From the original 5 to 7 foot slab may be obtained a strip 1/28 of an inch in thickness and 1/4 of a mile in length. Cold reduced steel must be annealed to ensure the necessary ductility and mechanical properties which make steel strip such an infinitely versatile and useful material. Lifted as though it were a feather, the heavy roll of steel is conveyed to the annealing department. After the coils are stacked on the annealing bottom, an air-excluding cover is placed over them. A protective gas is introduced under the cover to prevent oxidation. The portable furnace is as big as a small house. After softening in the annealing furnace, the steel strip will be retempered in the skin pass mill. Then it is ready to go forth into the community as steel of premium quality. Let's circle back now to follow another of the vast plant's many steel milling operations. Here, a red-hot steel billet rolls through 9 continuous bar mill stands where it is reduced in cross-section and run out to a length of 100 feet or more. The bars then pass through 8 or more stands of the merchant mills, emerging as a thin, narrow, continuous strip of hot-rolled steel. Again, the steel strip is neatly coiled. Then the ingenious conveying mechanisms take over. Down the roller table they move to the inspection stands, and without a pause, they're on their way. For steel is utilized just as rapidly as it can be prepared. In the remarkable plant of the Strand Steel Division, coils of steel are consumed in huge quantities. Steel strips racing through the cold forming mills are fashioned into strand steel framing, which go into the making of the famous Quonset buildings. Newly formed webs and angles are paired in the great gang welder to be fused into arch ribs. Other strips of steel are formed into studs and purlins, and the mass production system feeds the vast shipping area from which packaged prefabricated Quonsets are shipped by rail to every corner of the nation. Where steel from the Great Lakes plant, newly formed into Quonset members, is erected into shelters, the utility of which is unlimited. Thus, we've seen, in the big plant on the Detroit River, high-grade steel rolled into a great variety of useful forms. Beneath the vast lofts, different types of mills roll steel in many shapes. Here, in another bloomer, an octagonal ingot is prepared for the merchant mills. And at the far end of the process, the final product, rolled from the single ingot, becomes a thin, hot rod more than 1.25 miles in length. With rhythmic skill, the sure-handed stranders whip the white-hot ribbon around and back and in and out through the mill stands. This is a spectacle to be seen nowhere but in a big steel rolling plant. Brooding in its vastness and its power, from lesser, commoner efforts set apart, for where it bulks gainst sky, and great stacks tower, the mill embraces a fierce, unusual art. The stuff of dreams and vision bold, the compelling chemistry of the blast, the awesome spectacle, then behold, the fulfillment and the triumph of the cast. Rust of the earth, a reddish dirt garnered by giant crane. But men and mills must give it form, ere steel can be its name.